All right, let's get into this. You've brought us some really interesting material here, all focusing on business continuity, high availability, and disaster recovery.
Yeah, BC, HA, and DR, the big three.
And they feel incredibly relevant today, don't they? Everything's tied to the cloud, systems are interconnected.
Absolutely. And
Yeah.
when those systems go down, it's not just an IT problem anymore. It hits the business hard.
How so?
Well, you're looking at lost income. Maybe you can't deliver services people depend on. You might even breach contracts or commitments. It fundamentally stops the business from,
hmm
well, from doing business.
So our goal here is to unpack these terms, figure out what they really mean, how they relate, and pull out the key insights from this material you've shared. Sort of a rapid deep dive to get us all on the same page.
Exactly. And the sources lay it out quite logically. You've got business continuity BC, that's the overall aim, keeping things running.
The big picture.
Right. And supporting that, you have high availability, HA,
Hooray.
which is more about dealing with the common day-to-day glitches. And then disaster recovery, DR, which is your plan for the big, rare, catastrophic events.
So BC is the objective, HA and DR are the strategies. Let's dig into BC first. What's the core definition we're working with from these sources?
Consistently, it's defined as the state where a business can just keep operating, even when facing failures, outages, or, bigger disasters.
It's not just luck then.
Oh, definitely not. It demands really deliberate, proactive planning. You have to build resilience into your systems and your processes from the start.
And the why behind it, as the sources stress, is that tight link between tech and business. If the cloud service is down, the operation grinds to a halt. Lost revenue, unhappy customers.
Real consequences.
Yes, sir.
And a key point raised is making sure everyone involved, developers, operations, business folks, understands these stakes. What are the expectations? What happens if we fail?
Because there are always trade-offs, right? Perfect resilience costs a fortune.
Precisely. It's about finding that balance based on actual business needs.
Okay, let's look at those strategies. High availability first. What's the essence of HA?
HA is all about designing your specific systems, your workloads, to handle those common everyday kinds of issues. It's about meeting your defined uptime targets reliably.
Dealing with the usual bumps in the road.
Exactly.
And disaster recovery.
That shifts the focus to the uncommon risks, the big hits, catastrophic outages. How do you recover from those?
So HA for the frequent, DR for the infrequent but severe. And crucially, they work together. You plan them in tandem to achieve that overall business continuity. The sources seem very clear on that relationship.
Absolutely. They cover different scenarios, but both serve that same ultimate goal, to keep the business operational.
So how do you actually put this into practice? The sources mention a proactive planning process, starting with risk assessment. Where does that begin?
It starts with identifying your risks. What could possibly go wrong that impacts your system's availability or its function?
Okay.
Then you analyze those risks. How likely are they? And if they happen, how bad is the impact? Think downtime, think data loss.
The sources give some good examples, like network blips or VM reboots happen pretty regularly.
Right. Common stuff.
Hardware failures or maybe occasional. A whole data center outage, that's unusual.
Getting rarer.
And a whole region going offline is very unusual.
Yeah, hopefully very rare. But here's a really vital point the sources make. Don't just think about infrastructure.
Oh.
Human error is a huge factor. And things often siloed as security or performance issues like data corruption, bad software deployments, DOS attacks, even rogue admins or sudden traffic spikes if they impact availability. They are reliability risks you need to plan for in BC.
That really widens the net, doesn't it? Basically anything that stops the service from working when it's needed.
Exactly. It's about the outcome, unavailability. The sources also mention failure mode analysis, FMA, as a useful technique here.
AFMA.
Yeah, it helps you systematically think through potential failure points and how the system might react. What happens if this component fails?
Okay, so you identify all these potential risks. What's next in the process?
Classification. You sort those risks. Are they common, everyday things? That's for your HA planning. Or are they uncommon, major events? That's for DR.
Simple enough. Or is it?
Well, this is where it gets really interesting, and the sources highlight this brilliantly. The classification isn't always fixed. It can actually change based on how you've built your system.
How so?
Take that region outage example normally, a classic DR scenario, right? An uncommon disaster.
Yeah.
But if you've architected your application to be active across multiple regions with automatic replication and failover, well, suddenly losing one region isn't a disaster in the same way. Your system is designed to handle it. It becomes more of an HA consideration for that specific workload.
Wow, so your design choices directly impact whether you treat a major event as a routine HA incident or a full-blown DR situation.
Exactly. It shows how deeply connected your architecture is to your whole resilience strategy. That's a really powerful insight for the material.
Okay, so we've identified risks, classified them based on likelihood and our architecture. Step 3 is mitigation.
Right. Risk mitigation. This way you figure out what you're actually going to do about these risks.
Yeah.
Developing the HA or DR strategies to minimize their impact.
And this involves technology, I assume.
It often does. Things like redundancy, replicating data, setting up automatic failover mechanisms, having good backups. But the sources warn your tech choices must match the business recovery needs. Meaning, if the business says, we need to be back online in 15 minutes, you can't rely on a tech solution that involves someone manually restoring data for 6 hours. The tech has to meet the RTO.
Right, that manual step could kill your recovery time objective. The sources also mentioned tolerance for partial failure, like operating in a degraded mode.
Yeah, that could be part of mitigation. Is it okay if some functionality is down, but the core service remains? Sometimes yes, but mitigation isn't just tech, it's also human-based.
Human-based, like
Yeah.
training.
Exactly. Having skilled people ready to execute recovery plans, maybe switching to manual processes temporarily, but also building a culture where people feel responsible and, crucially, empowered to flag risks or concerns. The sources really emphasize this human element.
That's easy to overlook sometimes, focusing just on the servers and code.
It is. But the people designing, building, and operating it are critical. And because human processes can sometimes be slower or more error-prone than automation.
You need controls.
Exactly. The sources strongly recommend formal change control, especially for risky actions. Things like rigorous testing based on criticality, quality gates for deployments, and clear procedures for sensitive stuff like accessing production data, maybe requiring pair programming, checklists, peer reviews.
Adding layers of safety through process.
Precisely. Structured human processes are key.
Okay, that planning process makes sense. Let's dive deeper into high availability now. Remind us what HA is fundamentally about.
HA is about ensuring a specific workload meets its required uptime level day in, day out, handling the common stuff.
And required level is the key phrase there, because the sources stress that needs very massively, right? An internal tool versus a critical customer payment system. Completely different HA demand.
Totally different, even within one application, like e-commerce. Browsing products might tolerate more downtime than actually placing an order or processing fulfillment. You need that granularity.
And this is where we get into measuring uptime with nines.
Yep, the sorts break it down nicely. 99.9%, 3 nines means you can have about 43 minutes of downtime per month.
Okay.
Go to 99.95%, 3.5 nines, and that drops to around 21 minutes.
So the trade-off is pretty clear.
Very clear. More nines mean less downtime, but exponentially more effort, complexity, and cost to achieve. And remember, that target applies to the whole workload, not just one server. The sources strongly advise, don't over-engineer. Match the nines to the actual business requirement.
A very practical point. So how do you actually design for HA? What are the key elements the sources highlight?
First up, fault tolerance. Can the system keep working? Maybe partially, even if something breaks? Handling transient errors automatically, things like that.
Makes sense. Second.
Redundancy. Having copies. The sources talk about different scopes. Local redundancy within a data center, zone redundancy across different availability zones in a region, and geo-redundancy across regions.
And they give some specific Azure examples.
Yeah, like running multiple instances of an app service, maybe using the zone redundant option. Azure Storage automatically making multiple copies with options like ZRS for zones or GRS for geo. Azure SQL Database having replicas. Lots of platform features help here.
Okay. Third element.
Scalability and elasticity. Being able to handle load increases by adding resources, scalability, and doing it quickly. Elasticity. This is key for availability under load.
Right, because if load spikes and you can't scale, the system falls over.
Exactly. Or if one component fails, the others need to pick up the slack. So Azure tools like VM scale sets, API management auto-scaling via Azure Monitor, Azure Functions scaling automatically, Cosmos DB auto-scaling throughput, they all play a role. Sometimes you might even need to over-provision a bit if scaling isn't instantaneous.
Good point.
Zero downtime deployment techniques. Deploying changes is risky business for uptime, so you need strategies like updating subsets of instances, controlling traffic flow, monitoring closely, and having quick rollback options.
And Azure helps here too.
Sure, things like Azure Container Apps revisions, techniques in Kubernetes on AKS, phase key rotation in Azure Storage, using feature flags or snapshots in Azure App Configuration for config changes. They all aim to reduce deployment risk. Or if zero downtime isn't feasible, you plan maintenance windows.
This element.
Automated testing, sometimes called chaos engineering. This is crucial. You can design for failure, but you don't know it works until you test it by breaking things deliberately in a controlled environment. Azure Chaos Studio is mentioned for this.
You have to actually simulate the faults.
You really do. And finally, sixth, monitoring and alerting. You need eyes on the system, knowing its health, getting early warnings of trouble.
So using tools like Azure Monitor for logs and metrics, application insights for the app itself, checking Azure Service Health and Resource Health for platform issues, being aware of scheduled events for VM maintenance.
Exactly. All that visibility is critical for maintaining HA. Putting all those pieces together is how you build a highly available system.
Okay, great overview of HA. Now let's flip to the other side. Disaster recovery. How do the sources distinguish DR clearly from HA?
DR is focused squarely on those distinct, uncommon major events, the big disasters, things outside the scope of your normal HA design with potentially much larger impact.
And the examples given include natural disasters, hurricanes, earthquakes, but also big human mistakes.
Yep, like accidentally deleting a production database or a major firewall screw-up, and significant security incidents too, massive DDoS attacks or ransomware that corrupts everything or forces systems offline.
And a key difference noted is that with DR, unlike HA, some downtime and maybe even some data loss is often accepted, right? Because the events are so severe and rare.
Exactly.
Ugh.
Which leads directly to the core business requirements for DR planning.
RPO and RTO. Let's define those again based on the sources. RPO.
Recovery point objective, that's the maximum amount of data loss the business can tolerate, measured in time. Like, we can afford to lose up to 1 hour of data.
Okay. And RTO.
Recovery time objective, maximum acceptable downtime. Again, measured in time. We need the system back online within 4 hours.
And these aren't system-wide necessarily. They can be per application, maybe even per function.
Absolutely. And they come directly from understanding the business impact. What does an hour of data loss cost? What does 4 hours of downtime cost?
And the sources warn about aiming too low, right? RPO and RTO of 0 is often unrealistic.
Very unrealistic, or at least incredibly expensive and complex. It needs a serious discussion between business and tech teams to set achievable targets.
So, DR plans themselves. The sources say they're usually well-defined, might involve manual steps, and absolutely must be testable. Azure offers help, but it's not automatic. What are the key components of a DR plan?
First is failover and failback, having a secondary site ready and a plan to switch traffic and operations over to it when disaster strikes.
Using things like Azure Site Recovery for VMs or Azure Front Door Traffic Manager to redirect users to another region.
Exactly. But two crucial points here. The time it takes to detect the disaster and perform the failover has to fit within your RTO. And failback going back to the primary site later is often tricky, especially dealing with data that changed while you were failed over.
Needs careful planning. Okay, second DR element.
Backups, your ultimate safety net, for when failover isn't enough or data gets corrupted.
And key things to consider for backups.
Where you store them, definitely separate from the primary, usually another region. How much data you might lose, backups aren't continuous, so RPO matters here. And how long restoration takes that impacts your RTO. Backups are often the last line of defense in DR.
As your examples mentioned, were Azure Backup, automated backups in services like SQL or Cosmos DB, backing up Key Vault.
Right. Aligning backup frequency with RPO and restore time with RTO is critical.
Third element.
Automated deployments using infrastructure as code or IAC. Defining your environment in code bicep, ARM, Terraform.
Why is that important for DR?
Speed and reliability. In a disaster, you can use IAC to rapidly build out your recovery environment exactly as needed, much faster, and with less risk of human error than manual configuration under pressure.
Makes perfect sense. And the final, critical element.
Testing and drills. The sources hammer this home. A DR plan you haven't tested is basically just hope.
And test the people and processes too, not just the tech failover.
Absolutely. The sources put it starkly. If you haven't run disaster simulations, you're likely to fail when a real one hits. Testing is the only way to know if your RTO is realistic and if everyone knows what to do.
It validates the entire plan.
It really does.
Wow, okay. We've covered a lot of ground thanks to this material. Starting from that big goal, business continuity. Moving through the planning steps. Identify, classify, mitigate. Then really digging into high availability for those common risks. And finally, disaster recovery for the major hits.
Yeah, they really do all fit together. Understanding how BC, HA, and DR interplay, like the sources lay out, is just fundamental if you want to build systems and processes that can actually survive out there.
It really is. Thanks for sharing this. It provided a great structure for this whole discussion.
My pleasure. It's stuff that affects pretty much every digital service we rely on.
Absolutely. So, thinking about everything we've just unpacked, all the different kinds of risks, the HA strategies, the DR plans, the vital role of testing in people, here's something for you, our listener, to consider. If you think about a system or a process you know well, where's the first place you'd look now to potentially improve its reliability? What common risk, or maybe even an uncommon one, perhaps human or process related, might be getting overlooked right now?